make sense of the takeaways that you wrote down. So please take some notes and it'll help you make sense of it. When we talk about exponentials, the equation looks like this. This is the y-intercept on a graph. This part here is the growth factor or the decay factor. And there's a way to know if something's growing or decaying. Like we talked about yesterday, if something has a negative exponent, we could also write it like this. Because this part is a fraction, that means it's getting less and less each time. So that causes decay. Negative exponents cause decay, or bases that are fractions cause decay. So let me make sure that you know that there are some things that A can be and can't be, as well as what B can and can't be, in order to graph and understand an exponential function correctly. Okay. A is not allowed to be 0. If it were, you would have a function that was 0 times something to the x. And instead of your graph going up like this, it would just do this. Therefore, it's not exponential. Okay? Your b value cannot be 1 or 0. Here's why. If b is 1, a times 1 to the x, then your graph is doing 1 to the first power, 1 to the second power, 1 to the third power, which is always 1. So again, your graph flatlines, and that's not exponential. If your graph happens to be 0, or the growth rate happens to be 0, well, we know if we put in our calculator 0 to the 0, we're going to have problems. Okay. The other thing B is not allowed to be, it cannot be a negative number. In geometric sequences it can, but not in exponentials. Because if your base is like -2, then one time the value is going to be up here and be positive, but when you time something by negative, then it will become negative. And then the next time it's going to be positive and negative and positive and negative. And what happens is your graph is really doing that rather than being exponential. Okay. There are 4 ways that we can draw the graph of an exponential. Y equals a b to the x. Please remind yourself of what a represents and what b represents. Okay. If the graph is going like this, here's your y-intercept, your a, and your b is your growth factor. Maybe it's times 2, maybe it's times 5, maybe it's 1.3. If b is greater than 1, it will grow. If you have like a 10% earning in your savings account, you're going to have 100% plus 10%, which means your growth rate is 100% and 1%, 10%, or 1.1 for the growth. Okay, you could also be decaying. As we talked about yesterday, the only way to get an exponential to decay is if the base is a fraction. So the base has to be between 0 and 1, like 1/2, 1/3, 90%. Okay. In both of these cases, the A value is a positive number. We can also, and we talked yesterday that these things are twin powers. They are reflections of each other. Now, what if the graph did this? It started like the one above it and started close to 0, but then started going down. It's actually also still growth because the negative numbers are getting very big and they start out very small and close to 0. It's still growth. So B will be bigger than 1. However, as you can see, here's A, and it's a negative number. So A is negative. It's the only difference between the one above it. All right, if we can also have decay of an exponential, decay, we just said above that the growth factor, or in this case the decay factor, has to be between 0 and 1, so it's a fraction. But this time it's going to start very far from the y-axis, x-axis, and then get closer and closer. This case, A is also negative. Let's recap. In the top, the y-intercept is positive. For growth, hello child, if you can hear my kid, you're so lucky. I can do books. So if B is bigger than 1, it's growing. If B is a decimal or a fraction, it's decaying. The way to reflect that over the x-axis is for growth, your B will still be the same, but now your y-intercept, or the A part of the equation, is negative. It can decay, and the A will be negative, but it's going to start at a very large negative number and become a very, very small negative number and get close to this imaginary line we talked about. That imaginary line, by the way, remember it's called the asymptote.